incredible scientist. He spent most of his time at Caltech. The idea of quantum physics, where all these particles are interacting in mysterious ways, he came up with a thing called Fynman diagrams that he won the Nobel Prize for. Perhaps even more importantly, he was an amazing teacher. He did a series of lectures which were for people who didn't specialize in physics. It's such a great example of how he could explain things.
For me, what the best definition of science, or the scientific method that I've heard, comes from a very famous physicist called Rechard Fynman, who won a Nobel Prize for building one of the first quantum theories of electricity and magnetism. It's called quantum electrodynamics. This is back in the 1940s and 50s. It's our best theory today of how light interacts with matter. But Fynman was also, I recommend that you read his books. He was a brilliant teacher, a brilliant lecturer, as well as a Nobel Prize-winning physicist. And he gave this lecture back in, I think it was the 1960s, and it's just a 1-minute definition of the scientific method.
I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we no, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
Of course, I was an ordinary person who studied hard. There's no miracle people. It just happens they got interested in this thing. And they learned all this stuff. They're just people. At any rate, I think that the numbers are a problem in astronomy, the sizes and numbers. And the best thing to do is to relax and enjoy the tininess of us and the enormity of the rest of the universe. Of course, if you're feeling depressed by that, you can always look at it the other way and think of how big you are compared to the atoms and the parts of atoms, and then you're an enormous universe to those atoms, so you can sort of stand in the middle and enjoy everything both ways.
Dr. Fynman used a tough process on himself where if he didn't really understand something, he would push himself. Do I understand this boundary case? Do I understand why we don't do it this other way? Do I really understand this? And because he had pushed himself to have such a deep understanding, his ability to take you through the path of the different possibilities was incredible. That is a little mysterious to most people, and using very simple concepts to explain how it works. He doesn't even tell you he's talking about fire till the very end, and you feel like you're kind of figuring it out together with him. Fynman made science so fascinating. He reminded us how much fun it is, and everybody can have a pretty full understanding. So he's such a joyful example of how we'd all like to.
I'm sure there are other people here who could tell you about the Rechard Fynman they knew, and it would probably be a different Rechard Fynman. Rechard Fynman was a very complex man. He was a man of many, many parts. He was, of course, foremost a very, very, very great scientist. He was an actor. You saw him act. I also had the good fortune to be in those lectures up in the balcony. They were fantastic. He was a philosopher. He was a drum player. He was a teacher par excellence. Rechard Fynman was also a showman, an enormous showman. He was brash, irreverent. He was full of macho, a kind of macho one-upsmanship. He loved